time we finished out 1.7. So at this point, you should be able to do like all the way to 56 for the homeworks. That's the problem set that's due this weekend is just whatever to 56. I don't know, 25. Sounds right. But take some questions here, presuming that some of us have moseyed on in and started some of that homework, may have run into something that you're not sure about. Does anybody have any questions here on homeworks? Grace?
42.
42, sure. Okay, I'm gonna actually probably do that in 2 spots. Hannah, did I see you starting to raise your hand too?
Yeah.
Okay, you're next, okay? I'll just do that. All right, so asked us to do a bunch of stuff here. So it says determine if the following, or if the relation is a function. So I just do a vertical line test, right? None of these points are intersected more than once, or I could just look at the x coordinates and see that none of them repeat. Either way, correct. Feel good? The domain, well, that's just going to be the set of x's. Well, there's only, 5 x's, so -5, -2, 1, 3, 6. I can just list them with the little squiggly set bracket. Likewise with the range, so just listing the y's, -5, -4, 3, 5, 9. Again, just put them in the little squiggly set bracket. So far, so good? Okay. Determine if it's 1-to-1. So again, I'm looking for a horizontal line test, or I could just check to see if any of the y coordinates repeat. Nothing repeats. There's no horizontal line that intersects this more than once, so it's 1-to-1. Part D, since f is 1-to-1, f inverse is a function. Hi, how are you?
Good.
Good. Thank you. Miriam, for you. And then the last one, Grace says to find the inverse as a graph. So all I'm going to do is plot the 5 points with the coordinates transposed, right? So I'll graph 9, -5, 5, 1, 3, 3 just stays where it is. -4, -2, and then -5, +6. And then we're done. Yay! Was easier than the previous ones, probably. We just looked at it and we're like, I'm not sure what to do with this. But when you hear it, like, oh, I just think about it like the set of ordered pairs problem. Oh, okay. That's not bad. Miriam, what's up?
I was just wondering.
Okay, Hannah's next and then you.
Okay.
Perfect. Hannah.
26 and 27.
26 and 27. Okay. So 26 asks us to do, where did my pencil go? Where did you go? Oh, there you are. To do F compose G and then G compose F. So if I'm doing like F compose G, I'll rewrite that with the G, or the formula for G in place of the G. And I'm going to be plugging that into X everywhere there's an X in F of X. So to square a fraction, I just square the numerator and square the denominator. So 1 squared is still just 1. X squared is x squared. And I'm not going to bother with a common denominator or nothing there. That seems good enough. Feel okay with that, Hannah?
Yeah.
And then the other direction, we're doing G of f of x. So the f of x this time is x squared minus 3. So that means I'm going to be plugging that in for the x in G. So I'm going to have 1 over, but instead of x, I'm going to write x squared minus 3. So there's that. 27 says to do f compose g of 5. So there's kind of two ways you could do this. It says using a result from question 5. So your answer from 25 would have been this. So if I did f of g of 5, I'm plugging 5 in for the x, which is the square root of 1, which is just 1. Alternatively, if you hadn't already done that composition, you could have also thought about it this way. You could have done f of g of 5, where g of 5 is going to be, let me make sure, would have been x minus 4, so I'd have 5 minus 4. So that's just like f of 1, and then f of 1 would be the square root of 1. So you could think about it that way too, as like 2 steps, like plugging it into the inner, getting your answer, and then plugging that answer into the outer. Does that feel okay, Hannah?
Yeah.
Okay. Miriam, you're next, right?
Could you do 39?
Sure. Okay. So, is this a function? No, right? It fails the vertical line test. And then part B wants the domain and range. So for the domain, what I'm going to do is I'm going to go and look at the point on the graph that's furthest to the left, which appears to be that point right there, which looks like -1, 2, 3, 4, 5, 6, 7. And then I'll look at the point furthest to the right. Well, that's going to be the arrow. So that's positive infinity. And then since there's actually a point at negative that uses the x-coordinate -7, that's going to get a bracket. And the infinities always get a parenthesis. And I'll do the same thing for the range, except I'm going to start at the lowest point, which is here, the arrow pointing down. And then if I follow it along to the highest point, that's there, the arrow pointing up. So that's my range. So far, so good? Okay. Is this 1-to-1? I do a horizontal line test, right? Any horizontal line I draw only intersects this thing once. Good with that? And for part D, I can say I would say yes. And since f is 1-to-1, f inverse is a function. And then the last part D, asks us to, E asks us to graph or draw the graph of the inverse. So I'm just going to kind of pick a couple of points here to use. So I'm going to pick these ones because they look like they happen at whole number values. So this was 1, 2, 3, 4, 5. What's that? 1, 2, 3, 4, 5, 6. I guess that's supposed to be -6 there instead of 7. Miscounted before. And if I take this one, this is 2, -2. And this one would have been 2, and then 1, 2, 3, 4. Right? And now I'm just going to transpose these points. So I have 1, -6. 1, 2, 3, 4, 5, 6. I have -2, 2. So 1, 2, 1, 2. And then I have 4, 2. So 1, 2, 3, 4, 1, 2. And I'm just going to connect them. I'm going to keep in mind if this was the vertex before, that's going to be the vertex now. And I'm just going to kind of, oops, missed. We'll do it this way. Like that. And I'm done. Does that feel okay? Sure, no problem. It got messy because I had to zoom in too far to see the grid lines because it's hard in my eyes, My eyes! I'm just being weird for the sake of being weird to see if you're awake. Yeah.
Like 43 to 52, are you just like graphing that?
Yeah, absolutely. I would use the graph to do most of it, right? Aside from the last part where I would do that algebraically, because it wants the inverse as an equation, since it gave you the function as an equation.
And then you just have to like solve that for each.
Right. Yeah, you do that, get the x by itself, and then swap the x and y's. Yep. Exactly like we've done. Grace.
Do you know what 47?
Sure. I think I'm going to do this just to make it easier since we're going to be looking at the graph. So 47, 10 minus 4 times square root x plus 5. And then I'm just going to do a zoom standard. Again, I graph stuff all the time, all day. So like, who knows what my window looks like right now? I'm just doing that as a starting. So there's my function. That's 47. Is that a function? Definitely, right? Passes a vertical line test. So the domain, if I look, the point furthest to the left appears to be that right there, which looks like -5, 10 to me. So that's going to be my x. And since that's actually a point, I'm going to use a bracket. If I look at the point furthest to the right, well, it goes to the right forever. So that'll be positive infinity. And then the range, if I look at the lowest point, well, that's the arrow down here that's pointing down. So that's going negative infinity. And the highest point was up here, -5, 10. So that's going to be the upper for my range. And since it appears that there's actually a point there, I'm going to use a bracket. And again, to check, I could, if I plug -5 in for x, that evaluates out to 10, right? Because -5 plus 5 is 0, square root of 0 is 0, 0 times -4 is 0, and then 10 minus 0 is 10. So I'm sure that that's actually a point. C, Is this 1-to-1? Well, yes, it passes the horizontal line test. And since it does that, I'd say yes, since f is 1-to-1, f inverse is a function. And then the last piece is probably the part where we really have our question at, is to like, okay, how do I do the algebra to kind of get my inverse out of this? So the goal here is going to be to get the x by itself. Oh, come on, you stupid pen. So I'm going to start by subtracting 10 from both sides. And then make sure you hang on to that -4. It's really easy to lose track of that. And now I'm going to divide both sides by -4. So y minus 10 over -4, that's more like a 0, equals square root of x plus 5. And then to cancel the square root, we'll square both sides. And now I could multiply all that stuff out. I'm probably not going to, though. And then I can just subtract the 5 over. And from there, that's perfectly reasonable to swap our x's and y's. Now, certainly I could clean that up a little bit, but I wouldn't mark it down if you didn't. If you wanted to clean that up, you could FOIL out the numerator, x squared minus 20x plus 100, and then just make that a -4 squared on the denominator, and still have that -5. Like, that's an okay answer. Lots of stuff you could do. I suppose you could just multiply out the denominator. Just do it this way. I forget what the answer in the answer key looks like, but like any of those three is fine. Like they're all equivalent. Does that feel okay? So a lot of these ones, like the answer on the answer key is just like one of many possible simplifications. If you have something that's equivalent and just not simplified as much or simplified differently, it's fine. Like I'm not, you gave me an acceptable answer. Hi. Thanks, Jacob Samuels. I know. Standing up is hard, man. Hard. Anybody else on the question front? You want to just hang for a minute after we talk about the test, and then we're just going to have like the last half of class to just kind of doodle around and get ready for stuff. So, can you give me that much?
I will.
Okay. All right, so let's talk about the test. Again, when's the test? Yeah, next class, right? So this test is going to cover sections 1.1 through 1.7. That does not include 1.8. We'll do 1.8 at a later time where it fits more naturally into what we'll be doing in trigonometry. So I don't want to like do that now and then have to redo it again like a month later when we get to kind of where that fits in. So we're just going to wait and do it then. The skills you should be able to demonstrate on the test is you should be able to determine if a function is, or if a relation is a function. I have 4 questions where I ask you to do that. Remember, we've represented a relation in 4 different ways: as a mapping diagram, a set of ordered pairs, a graph, or an equation. You should be able to determine if any of those are a function, regardless of kind of the form that I represent it in. You should be able to find the domain of a function algebraically and then give your answer in interval notation. I'll have 2 questions like that. Remember that the trick for that is you take the stuff under the radical and set that greater than, oops, where did that go? Greater than or equal to 0. And then the stuff in the denominator we just set equal to, or not equal to 0. You'll have 1 question where I ask you to write the intervals of increasing and decreasing given a graph. I spelled that wrong. 1 question where I ask you to find the extrema with your calculator, so using those max and min commands on your calculator, and then to classify them as local or global max or mins. 1 question where I ask you to prove if something is odd, even, or neither. 1 question where I ask you to find all the vertical and horizontal asymptotes for a function and to justify those answers with a table. Or I probably should say with tables. 2 questions where I ask you to do function operations, so add, subtract, multiply, divide, or compose 2 functions. 1 question where I ask you to find the inverse of our function, and I might give you that function as a mapping diagram or a set of ordered pairs or a graph or an equation. And then 1 question where I give you 2 functions and I ask you to show that those 2 are inverses. We might say, be specific here, using composition. So using function composition to do that, showing that like f of g of x is equal to x and g of f of x is equal to x, like we've done in the notes a bunch of times, right? That's the test format. I think that's 14 questions if I count them up. Is that too many or too little?
No, that's just not what I'm used to. It's like not that bad.
Okay. Well, again, hopefully the idea is that this shouldn't be hard, right? Another piece, reminder, for every test in this class, you get half sheet of notes. A couple of things about the half sheet of notes. Needs to be a half sheet, not a full sheet, one-sided. You can write on either side of your half sheet. And it needs to be turned into me before the first section of this class takes the test, which would be Monday, 3rd hour. Ideally, you'd hand this to me today, and I'll hold it to you and give it back to you. If you need to email me a picture, I'll print it off and hand it to you on the test day. If you catch me Monday morning, you can give it to me then, or during community time on Monday, that would be fine. But I need to have it in my hand before the start of 3rd hour on Monday, or I will not let you use it on the test. Similarly, if you're absent on the test day, you forfeit your half sheet for a makeup. So makeups, you don't get to use your half sheet of notes. Just reminding. Any questions about that piece? What can you put on it? Anything you want. You can have example problems. You can have instructions on how to do something. You can have like the steps to doing things on your calculator. You know, like definitions. Whatever you want to put on there, it is your half sheet. I won't quibble about any of it. I just need it turned into me before the first section takes their test. That's all I got for today. I'm going to stop the recording and let you guys work on your review or your half sheet. Reminder that there is a review in the OneNote. So if you look at this, it's like the same kinds of questions. It goes all the way, this goes through 1.8. Notice the last 2 pages are about 1.8. When you get to these questions, you can ignore them. You do not need to do them. Your test does not cover 1.8. I have the key with worked out solutions attached. So Make sure that as you're doing things, you're checking along the way. And before you put something on your note card or whatever, that you've checked it, made sure that you did it correctly or whatever. This will come in a second. I don't want it to be so laggy. There it goes. That's due not this Sunday, but the following Sunday. I assume some of us may not start working on this till the day before the test. That's fine. I recommend doing that. Not doing that, but it is what it is. So this is not due till next Sunday's problem set. What's due on this Sunday? Like 25 to 56 or whatever the numbers were. I think that was it. Does everybody feel cool about what's going on, what we're doing for the rest of the day? This is it. So it's just working on either your review or your note card or asking me personal questions about things that you're not sure on or whatever else. But I'm done. Okie dokie. Miriam?
For the review packet, like, how close would you say it is to, like, the test info you gave us?
So I would say that everything test info wise that I gave you is probably on here. Are there things that I didn't say that are also on here? Yes. Is the level of questions on the review going to be harder or easier than the test? Potentially harder. Okay, the questions could be harder than the test question in terms of like the algebraic complexity. And then, is this going to be longer or shorter than the test? Should be longer because it'll include like all possible variations of like a problem type, right? On the test, I'm not going to do every variation because, quite frankly, I don't want us to be here for the entire day trying to do this, right? I'm just going to pick some of the stuff that I think is pretty representative of where we spent most of our time, or that I think is an appropriate level of difficulty for a test setting where it's timed and, you know, like closed notes, you know, you have your half sheet or whatever, but you don't have like infinite resources to like look stuff up on. Okay, doke? Yeah. Thank you for waiting.